Hello, my name is Hideo Nagahashi. Then today I want to talk about the inverse functions. So let me start. So as you know, the function means you have an input and then you associate another number, which is output. Okay. Then for the idea of inverse is you just switch the input and the output, and then now you look at this for the reverse, okay, the association here. Okay. So now for the inverse, so this is going to be now your new input. Then, so your old input is going to be your new output here. Okay. So let me start from the easy example first. Okay. So the first example, for example, you look at y is equal to x plus 2. Okay. So just adding two functions here. So y is the output and the x is the input. But now, if you switch the input and the output, so now you can view this as x is an output and then y is your input. So how do you express this? You simply solve this one for x. So x is equal to, you simply just move plus 2 to here, so that's x is equal to y minus 2. Okay? So in other words, the inverse of the adding two function is subtracting 2. Okay? So as you intuitively see, so plus 2, add 2, and then subtract 2, they are inverse each other. Okay? Let's look at another example. Okay? So instead of now adding 2, let's look at multiplying by 2. Okay? So y is a function of x. So this is a doubling function. So in the equation, so you can just write y is equal to 2x. Then now, what is the inverse of this? Okay? So again, you can find the inverse by solving this for x. So to solve this, so you simply divide both sides by 2. So you get x is equal to y over 2, or you can say x is equal to 1/2 times y. Okay? So in other words, you can just say that the inverse of the doubling is like a inverse of multiplying 2, so is dividing by 2. Okay? Now, let's look at another example here. Okay? Let's look at the square function. Okay? So this time, you can write y is equal to the expression of x, which is just x squared here. Okay? So now, what is the inverse? Okay? This case, unlike other two examples, so we have a trouble. That because, for example, 3 goes to 9 by squaring function. Okay? However, you have another number whose square is 9, namely negative 3. Okay? So the negative 3 squared is also 9 because negative times negative is equal to positive. Okay? So that's why if you want to consider the inverse, so now you consider 9 to be a new input. So what is the output? Remember, for the function, each input, you have to have a unique output. So in this case, you have trouble. Okay? So that's why as is, so the function y is equal to x squared has no inverse. Okay? So that's why if you really want to have inverse, so you have to specify, okay, either x is positive or negative. Okay? So let me write this in here. Okay. So for the third example, so what I really want to do is to get the inverse of a square function. I have to say y is equal to x squared together with, I have to specify x is either positive or negative, like this. Then, well, the 0 squared is 0. So that's okay to get the inverse. So I just specify positive or 0. Okay? So then I can really solve this one for x. X is, so now if I solve this one for x, then the inverse of square function is the square root. So I have that. Okay? So this is the inverse function here. Okay? And then if I specify y equals x squared together with x is negative or 0. So this case, I can solve for x also, but now I have negative square root. Okay? Y. Okay? Okay, so now let me define the inverse function in general. Okay. So if you have a function, okay, y is a function of x, okay, then for each y, if we can specify the unique x, so then in this case we say x is an inverse function of the y is f of x, and then write this as a symbol, f raised to, no, it's like a f raised to the negative 1, but we read this one as f inverse, so we don't call this negative 1. Okay? So here, so f inverse here. So going back to these three examples. So for example, example 1, you have f of x, well, it's y is equal to x plus 2. So now let's call this f of x. Okay? Then remember, this one is x is equal to y minus 2. So that's why now I just call this f inverse. So the inverse function of the adding 2 is subtracting 2. But remember, this letter is really dummy. Okay? So what this really says is just whatever input, so you have to subtract 2. Okay? So that's why, since people usually prefer to use x as an input, so sometimes the people prefer to switch back to x. So instead of using y here, so sometimes people write this. So x minus 2, but it's really, now you can get rid of parentheses here. Okay? So that's why now, in short, we say f of x is x plus 2, and f inverse x is x minus 2. So these two functions are inverse functions here. Okay? Okay, thank you.